Good morning, students. Now we will start the chapter 7 and the part proportion. This is from exercise 7.2. As you have already studied about the equivalent ratios in your previous exercise 7.1, and you all know that here we have 1 is to 3, and the equivalent ratio of 1 is to 3 is equal to 2 is to 6, because here the antecedent is multiplied with 2, that is the first term, that is 1 is multiplied with 2. See, this one is multiplied with 2 and this 3 is also multiplied with 2, and we will get 2 is to 6 as the equivalent ratio of 1 is to 3. So as those two ratios are equivalent, so that means those two ratios are in proportion. Now see the second example, that is here we remind about the simplest form of ratios. You all know that if we have a ratio like here we have a 18 is to 12. Now in order to get the simplest form, here we can divide the antecedent, that means the first term, and the consequent, that is the second term, with 6. 18 divide this 18 divide with 6, we will get 3, and if this 12 is divided with 6, we will get 2. So that means here this 3 is to 2 is actually the simplest form of this ratio 18 is to 12. So as those are equal, so those ratios are also said to be in proportion. So 18 is to 12 is proportion to 3 is to 2. See, we have one more example, like the ratio of milk and water is given here 5 is to 1, and the ratio of fruit juice and water is given here 2.5 is to 0.5. So here this 2.5 can be written as 25 by 10, and 0.5 can be written as 5 by 10, as you all know about decimals. So after multiplying the antecedent, that is the first term, this is the first term. See, this first term is multiplied with 2 and the second term is also multiplied with 2. Here we will get 5 is to 1 again, that is the ratio of fruit juice and water in the simplest form, 5 is to 1. So first we consider ratio of milk and water, this is also 5 is to 1, so those two are equal. That means the ratio of milk and water is equal to ratio of fruit juice and water, that is 5 is to 1 is equal to 2.5 is to 0.5. So those ratios are said to be in proportion. That means those ratios are proportion. Now if we have four numbers and we have to find out that whether those are in proportion or not. See, we have those four numbers, and how we can clear that those four numbers are in proportion or not. See, for this we take the first two term, 4 and 14. So this 4 and 14, the ratio of 4 and 14 become 2 is to 7, and the second two term we have this 2 is to 7. So that means this 4 is to 14 is equal to 2 is to 7, and this 4 is to 7 is 2 is to 7, and this 2 is to 7 is equal to 2 is to 7. So we have two equal ratios, equivalent ratios. That means this 4, 14, 2 and 7 are in proportion. Now see, one more example we have 60 is to 12. See, 60, 12, 40 and 8. Now first we take the first two term. See, 60 is to 12 becomes 5 is to 1, and 40 is to 8 becomes 5 is to 1. So that means those are in proportion. Sometimes, like in the exercise in question number 3, we have the terms which are not arranged like this. That means here in those terms, those numbers are in order, but here in question number 3 we have to we have four numbers, we have arranged those numbers in a proper order, then find out whether they are in proportion or not. So carefully solve question number 3 by changing the place of the number, that means changing the order of the number. That means you can see in the first question, that is 3a, you have 5, 2, 4 and 10 in the question 3a, 3 bit a. So here you can rearrange the order like 5, 5, then a 2, then 10 and 4. So this becomes in a proportion. Now you can rearrange those numbers again and find out whether they are proportion or not. That means you have to do it 2 or 3 times to find out whether they are proportion or not. Now come to the next point, that is extreme terms and mean terms. See, here we won't take any number. Here just we have consider P, Q and R, S are in proportion. That means P is to Q is proportion to R is to S. So the extreme terms, that means the terms at the ends, at the initial and at the last of the term, last of the proportion, those terms are called extremes, and in the middle those terms are called means. In proportion, when those terms are in proportion, then there is a condition, there is a relation of means and extremes, that is, see, the product of extremes is equal to the product of means. This is the relation. When those are in proportion, the product of extremes is equal to product of mean. See, for example, we have taken 60 is to 12 here and 40 is to 8 here. Now see, the product of the extreme 60 into 8 is equal to 480. Now you can see the product of means, that is 12 into 40 is equal to 1240 480. See, the product is equal, 480 and 480. You can see this is the product which is equal, 480 and 480. This is the product of mean and this is the product of extremes. So those are equal. So this is the relation when we have a proportion of 4 number. Now come to the next point. Find out a missing term in proportion. So it is a very easy task. First we consider this example. See, we have 5 is to 2 is to 10 is to x. Here x is the 4 term. Sometimes you have the question like in question number 4, you have 3 terms and you have to find out the 4th missing term of the proportion. Here you have 3 terms, like in question, the question it is given that 5, 2, 10 and find out the 4th term of the proportion. So here you just consider that x is the 4th term and arrange those as in proportion, and now you can solve by whatever the relation you have of the means and extremes. So see, this is the product of the extremes, that is 5 and x. Now here we have the two means, that is 2 and 10. So product of 2 means 10 into 2 is equal to 20. So you can get 4 here. So x becomes 4, that is the mean term. That is the that is the last term, that is the 4th term of the proportion. The missing term of the proportion is found out. Now see the other example we have here, that is 6 is to x and 4 is to 0.8. Again we will do the same, that is we multiply the extremes, see, and multiply the means. We will get the value of x as 12 by 10, so it will be 1.2. Now the missing term is 1.2 here in the place of x. So in this way we can find out the missing term of a proportion. Now come to the next point, continued proportion. See, we have now continued proportion. See, one second. See, this is continued proportion, and in the continued proportion, as you have already read about continued ratio, that is when two ratios are equal in such a way that the consequent, that is the second term of one ratio, is equal to the first term of the another ratio, that is the consequent of one is equal to antecedent of one, then those ratios are, then that ratio is called continued ratio. Here p is to q is to r. This is the ratio given. Now when we arrange this one in proportion, then we will have P is to Q. P is to Q, because P by Q is equal to Q by R. So this P is to Q is equal to Q is to R. So here we will also follow the relation of product of extremes and product of means. So this P into Q is the product of extreme, and this Q into Q is the product of mean. So here we will have the revised relation, the product of extremes is equal to mean into mean or mean square. So in this way we can solve some of the questions, like if we have the three terms of a continued proportion as 3, 9, 7, 9 and 63. So the product of those two extremes is equal to C, and the square, that is the square of means, that is 9 into 9. 9 is the common mean in the continued proportion, so 9 into 9. So here 9 into 9 is 81. As you can see here, this 441 is not equal to 81, so that means those are not in proportion. If those are in proportion, then see here those are in not proportion. Now we have 7, 21 and 63 as the three terms of a proportion, and here 7 and this 7 and this 63 are the extreme terms. So after multiplying we get 441. Now the mean is 21, and 21 into 21, that is mean square, is equal to 441. So see, 441 is equal to 441, that means those are equal. That means those numbers are in continued proportion, 7, 21 and 63 with the mean 21. So we can write in proportion 7 is to 21 is equal to or is proportion to 21 is to 63. So those are said to be in continued proportion. Now see the next point, we have to find out the missing term, the missing mean in a continued proportion. See, we have two extremes here in the question 5 and 6. It is given that two of the extreme, that is here we in the example we consider 1 and 9 as the two extremes. You can see here those extremes are given, and you all know that the mean square, that is the relation, the product of mean, that is mean square here in continued proportion, is equal to product of extremes. Here extremes are 1 and 9, so product of extreme is 1 into 9, that is 9, which is 3 into 3. So that means mean square is equal to 3 into 3, so mean becomes 3. So this is the answer we have, the missing mean we have. Now we can do the same with a different way. See, 1 is to, that means if we have two extremes 1 and 9, so we can consider that x is the mean here and arrange the proportion like that, 1 is to x is proportional to x is to 9. Those are the common means and those are the extremes. So the product of extremes 1 is to 9 is equal to x into x, that is the product of means, that is x square. So you can write here x is equal to 3. So in this way we can solve all the 6 questions given in our exercise. Thank you class.